Okay, let's do a small recap. Yesterday we have just started discussing about what is a lambda expression. So you can answer this. What is lambda expression? It is an anonymous function. And what is anonymous? Nameless. Okay. And when it was introduced, 1.8. This answer is enough, sufficient. And how to write an anonymous function? Okay, any function with no name, no modifier, and no return type. So you really don't have these concepts for anonymous function. So benefits, so you have these benefits. That's it. You can answer your interview question. Yesterday we have also discussed how to write lambda expression. So this is the basic syntax. So you have the parameters enclosed in parentheses, and this is very important. The arrow token. Okay, arrow token followed by the statements, right? And this is just the typical explanation for this syntax. So how to use lambda expressions? Okay, to just to functional interface. Okay, we need to understand the concept of actually this is opposite to invoke lambda expressions. We use functional interfaces. Okay, so today I will explain you what is a functional interface, and we will discuss this functional interface, and we will link how we can utilize the lambda expressions by using functional interfaces. Okay, so what are the other concepts that we have discussed? So I want to just give you the small picture. So if you have one parameter, you need to remember these points, guys. The points that I'm going to explain now. If you have one parameter, like if you have no parameter, the expression of the lambda would be like this: system.out.println. Okay, so you can just pass hello. So this is one scenario that we have discussed. And if you have more than one parameter or more than one parameter, let us say that if you have two parameters and you are passing two variables, okay, variable a and variable b, which is of integer type, right? And this is how the typical lambda expression looks like. Okay, and you can optimize this further. So based upon the context, compiler is clever enough to recognize the data types of the variables. Okay, how I can do the further optimization, right? The further optimization, it could be like this. You can just remove the data types, and okay, this is how the further optimization of this code is going to be. Okay, this is the second scenario, right? And the third scenario would be like, okay, if you have only one parameter, right? System.out.println.length. Okay, so we are passing only one parameter here, one parameter in the form of string data type. Okay, if you are passing only one parameter of the string data type, you can do optimization. First optimization is data type is not required, because based on the context, compiler is going to recognize the data type. So you can just pass the variable name, and you can keep the same statement. And since it is only one parameter, this parentheses are also optional. So this is how the simple code does look like. Okay, so system.out.println s dot. I mean, since it is returning something, right? So this is not required. System.out.println is not required. It is returning something. Okay, this is how the one of the examples that we have discussed yesterday. And the last case is, and if you have the body of the lambda expression has more than one statement. Okay, if it is one statement, you can remove the parentheses. If it has more than one statement, it is mandatory to keep the parentheses. It is mandatory. For one statement, you can remove this parenthesis. For more than one statement, it is mandatory. Okay, just remember all these lines, and we will do a small task on top of that. Okay, after completing this, we will just start about functional interfaces. 1 minute, guys. My screen is stuck. Okay. Okay. Now, if you see, please remember this: the characteristics and the properties of lambda expression. A lambda expression can have any number of parameters. First point. So, what does it really mean? What does it really mean? Let me bring this down. Okay. So when you are designing, when you are trying to create a lambda expression out of a method, this lambda expression can have one parameter, or it can have it can have no parameter, it can have one parameter, and it can also have more than one parameter, any number of parameter. Right? When you talk about parameter, it can have no parameter, can have only one parameter, it can have any number of parameters. This is the first case study. Okay. So what is the second case study? Please be informed that if there are multiple parameters are present in the lambda expression, it should be separated. Okay. If it has multiple parameters, for example, this case, you can have integer a comma integer b comma integer c. Okay. So there are more than one parameter. If you have multiple parameters, this parameter should be separated by what? Comma. Okay, that should be a separator, right? And if only one parameter is present, then the parentheses are optional. For example, okay, if there is only one parameter like string s, anything string s, you can remove this parenthesis also. It is not required. Right? You can remove this parenthesis. If you want, you can keep, or you can remove this parenthesis also. It can be further simplified to. Okay. Data type can be removed. Parenthesis can also be removed. Okay. So see, please be informed that we can also specify the type of the parameter, and it is optional if the compiler expects the type based on the context. The fourth point. It says, fourth point says, if you have two parameters like integer a comma integer b, so it is saying you can keep the data type or you can remove it, as it is an optional, because compiler will recognize the data type based on the context. So this concept is called as what? Type inference. Okay. And the fifth line says, similar to Java method, the lambda expression can contain any number of statements in the body, and it is mandatory to keep them in the curly statements. What does it really mean? If you are generating any lambda expression, if there is only one statement in the body, these curly braces are optional. Okay. If there is more than one statement, these curly braces are what? Mandatory. Only one line of code. If you have only one line of code within the body of the lambda expression, then you can remove this. If not, it is mandatory to keep the curly braces. Right. And the last one, please be informed that return keyword is optional if the method body has only one statement. Right. So we have discussed this thing yesterday. It's just a recap, guys. That's it. You are passing string s return s dot length. If your code is designed like this, okay, this return keyword is also optional itself, so it can be simplified like s dot length. Okay, so that's it about the lambda expression. We got to know how to create a lambda expression, and today we will try to understand what is functional interface. Functional interfaces. Okay, so you can remember only one word with respect to functional interfaces. So when you are getting a question like what is functional interfaces, the answer is just remember SAM. Just keep this word in the mind. SAM. Okay. What do I mean by the word SAM? SAM means single abstract method. If you remember this word, then you can construct the definition, right? So any interface that has single abstract method is called as what? Functional interface. That's it. This is the straightforward interview answer. So what is a functional interface? Any interface that has single abstract method. Okay, that is called as functional interface. So what are the examples? What are the examples of functional interfaces? That could be the follow-up questions. Okay, there are examples like there are the real-time examples in Java and Java library. If you want to give them some examples, you have runnable interface. In the runnable interface, you have the run method. We will discuss each and every interface. Don't worry. You have callable interface. So these are the specific interfaces that you can give them for the examples. As an example, you can give them, and this is the interface name. And inside this interface, you have only one method, which is called as run method. This is another interface name which you have in the Java library, and inside this interface, you have a method called what? Call method. Right? And comparable, we have discussed this comparable interface in the collections framework classes. So inside this comparable interface, you have only one method, which is called as what? compareTo method. compareTo method. Right? So again, what is the purpose? Why we should go for functional interfaces? That could be the follow-up question. What is the purpose? Okay, the purpose is, what is our actual intention of learning functional interface? Right? To invoke Lambda expression. Okay, the second purpose is to achieve backward complexity, compatibility. Backward to achieve backward compatibility. So that's it. I can give an interview answer. So if you get a question like what is functional interface, okay, what is functional interface? Okay. Just remember this keyword SAM. Any interface that has single abstract method, it is called as what? Functional interface. And examples. Okay, these are the few examples that you can give them. What is the purpose of functional interface? To invoke Lambda expression to achieve backward compatibility. Okay, so this is the functional interface. Now the question should be triggering in your mind, what is functional interface practically, right? So very simple. So we know how to write an interface, guys. Okay, focus here. So the practical part starts from here. Okay, we know how to write an interface. So how you can write a class? You know how to write a class. So class, if we ask you to write a class, so this is the keyword that you use for class, and you do what? You give the class name of the class name, followed by the body of the class, and you can keep any number of statements. This is how a class can be designed, isn't it? The way you are designing the classes, the same way you design the interfaces. We have discussed the interface already. Okay, you will use the keyword interface. So you use the interface keyword, you can give any interface name. So this is up to you, but the name should always starts with the capital letter, uppercase letter. Okay, so let us say that the interface name is test. Okay, this is how the interface looks like. So when you do this, interface is already ready, right? So what it when this is not a functional interface, when I can call this interface as a functional interface? Okay, what you have to remember, the word SAM. SAM means single abstract method. What did I say? abstract method. Any method without any body. For example, if I keep the method like public abstract void m, okay, method without body. That's it. So you can call this as what? The function interface. Why I can call this as function interface? By definition, any interface which has only one abstract method. By definition, any interface which has only one abstract method. So you can call that interface as what? The functional interface. So now these lines of codes are qualified enough to be called as what? The functional interface. Okay, this is one condition. This is one condition. The another thing that you have to remember is from Java 8, the concept of functional interface has changed. Okay? How it was changed? Yes, you are correct that it is going to have only one abstract method. At the same time, okay, that interface can have many static methods and many default methods. Okay, this is the second point. Okay, you understand. I hope you have understood about the first point. Now we are trying to understand the second point. Okay, second point is also very important. Okay, ideally, any interface which has only one abstract method is called as functional. At the same time, you can have default method. So default method is any method with the default keyword is called as what? Default method. Okay. And you can also have static methods. Void m3. Okay. So now, if you look at the case 2, so this is the case 2. Let me cut short this. Okay, focus here, very important. This is case 2. Okay. Hey, can I call this as functional interface? Can I call this as functional interface? Yes, this is also a functional interface. Why this is a functional interface? I have just said that an interface which has only one abstract method is called as functional. Yes, the restriction is applied only for the abstract method. Abstract method is the method which has no body, right? If you look at the if you target the abstract methods, according to my definition, okay, there is no violation with respect to abstract methods. So you have only one abstract method. You have only one method, no matter how many default methods you have. You can have 100 number of default methods, you can have 100 number of static methods. Okay, there is no restriction for default methods. There is no restriction for static methods, default or static, default and static. No restrictions. Okay. The restriction is applied only for the abstract methods. If you are keeping an abstract method, that should be only one abstract method, and you can have n number of default methods, no issues, and we can have n number of static methods, no issues. Still, the interface is called as what? The functional interface. You can tag this interface as functional interface. Don't worry about this. What is default method? What is static method? We will understand that. Okay. By definition, these two cases are valid. Only one abstract method. Let us try to understand some case studies on top of these interfaces. Okay, the case 1. So you need to answer me. Okay. So interface A. So I'm taking the name of the interface as A. Okay, this is the case 1. Hey, can I call this as function interface? Can I call this as function interface? I cannot call this as functional interface. Why I cannot call this as functional interface? Because this is an empty interface, an interface with no abstract method. Interface is complete empty. So this interface is not qualified enough to what? To be called as what? Functional interface. Okay. Case 1. Okay. Case 2. So interface A. Okay. And now what I am doing? I am taking abstract methods, public abstract void m1. Okay, public abstract void m2. Hey, can I call this as function interface? Case 2. Can I call this as function interface? Okay, so what is the requirement to for an interface to be called as functional? It should have only one abstract method, but here there is a violation. I have just placed two abstract methods. So this interface is also not qualified enough to be called as what? Function interface. Case 2, right? And the case 3. Case 3. What is the case 3? What does the case 3 says? Okay. Interface A public abstract void m1. Okay. Can I call this as function interface? Yes, you can call this as function interface, but because this is the typical interface which has only one abstract method. It should always be one abstract method. Okay. When it has only one abstract method, then it becomes the functional interface. Okay. Case 4. Case 4. Interface A. Okay, and I want to keep one abstract method. Okay, along with this, I also want to keep what a default method. Default void m2 and static method. Public static. So any method that comes along with the default keyword is called as default method. Any method that comes along with the static keyword is called as static. Okay, can I call this as a function interface? Okay, and if you are getting this question, yes, this is qualified enough to be called as function interface because the restriction has to be applied only for the abstract methods. Okay, and you can have any number of default methods, any number of static methods. So there are no issues. So this interface is completely qualified enough to be called as what? Function interface. So now you are able to recognize what is a function interface, how the function interface looks like, right? And I want to introduce an annotation. Okay, this annotation is also very important. At the rate functional interface annotation. Okay, at the rate functional interface annotation. For example, in the real-time applications, I want to design an application, guys. So just remember that I am trying to design an application. Let us take this space. Okay, I am trying to design an application. I have, I have created an interface like interface A, and I am keeping one abstract method inside. Public abstract void m1. Okay, so this code has been designed by me. I have just placed a simple code, and I have created and I have developed an interface, and I have just placed the abstract method. Okay, if I want the compiler to keep checking, or if I want to ensure that this interface remains as the functional interface forever. So here the option is, so this is the code developed by me. Tomorrow some other person, okay, my co-developer will come, right? He tried to change the nature of the interface. So now, so by looking at this code, I can just say that yes, this is a function interface. By just looking at this code, I can conclude that okay, through the visibility, I can say that this is functional interface. Okay, does that mean that it is going to be the functional interface forever? It is going to remain as a functional interface forever? No. If tomorrow my co-developer comes and if he adds another method here, like public abstract void m2, okay, now it is going to lose the identity of functional interface. Now it is not, it is just an interface now. There is no functional layer. Because there is a violation here, my co-developer has added another method, another abstract method, which is not qualified enough, okay, which is removing the qualification of the functional interface. Now this is not a functional interface anymore, but I want to ensure that this interface remains the functional interface forever. I want to ensure that compiler keeps checking that this interface is going to be as a functional interface forever. If you want to do that, I can just do what? If my co-developer is trying to add, my co-developer is trying to add another abstract method. If I want to ensure that my co-developer is also not adding this another method in the existing interface, what I want to do, I want to annotate this interface with the functional interface annotation. Okay? Just on top of this, just on top of the interface, please ensure that you are placing what? Functional interface. So what is an advantage of keeping the function interface? Your co-developers will not make any changes firstly. Okay, if the co-developer is trying to add another abstract method, the compiler will what? Compiler will scold him. Okay, compiler will not allow this to happen. This is not allowed. First point. Okay, this is not allowed. Second point is this interface will be going to be remaining as the functional interface forever. Okay, you are placing a check. You are placing a check that you are giving you are taking the help of the compiler, so that compiler will ensure that this interface is going to remain as a functional interface forever. If you are not keeping this, then today the interface can be functional interface, tomorrow it can be non-functional interface, and it keeps getting changed depending upon the methods that you are going to add here. Right? Why these checks are very important? Because I have just mentioned this, but remember this point, to invoke lambda expression. Okay, if I am trying to use a lambda expression, focus here guys, if I am not keeping these checks, okay, if I am trying to let us say that, let us understand that this functional interface is completely dependent upon a lambda expression. Okay, I am trying to invoke the lambda expression by using this function interface. By using this function interface, I am trying to do what? I am trying to invoke the lambda expression. Okay, this lambda expression is completely dependent upon the function interface. Only with the function interface you can invoke the lambda expression. Okay, let us imagine that already you have connected a code in the form of lambda expression, right? And you are using lambda expression to invoke what? To invoke, you're using function interface to invoke lambda expression. This lambda expression is completely dependent upon the function interface. Dependency. Dependent upon functional interface. Okay, so in order to ensure that this interface remains as the function interface forever, I need to keep this. I need to keep this annotation. If I'm not keeping this annotation, okay, it means that this interface is vulnerable to get changes. Right? In future, my friend can add a different another what we call it as, my friend can add another abstract method here. If he is adding another abstract method, okay, let us say that now this code is not having any annotation like functional interface annotation. Okay. The code is not having functional interface annotation. Yesterday it was functional interface. Today my friend has added this new line of code. It has become non-functional interface. If it is a non-functional interface, then the code, the lambda expression will be broken. Because only one way to invoke lambda expression is what? To invoke lambda expression, you require functional interface. But in future, if someone is trying to break the rule of functional interface, the statement that you're writing for the lambda expression will become broken. In order to ensure that this lambda expression is not getting broken at any cost, you need to ensure that this interface is going to be remain as a functional interface forever. Okay, in order to ensure that the compiler is checking that the interface is going to be a functional interface forever, just keep this annotation on top of it, so that no changes can be done. The interface is going to be remain as a functional interface forever, and there will be no issues with the lambda expression. So this is the importance of what annotation? The functional interface annotation. Okay, I can write this. Just ensure that you develop any interface, and if you are keeping what? You're keeping a public abstract void m1, right? On top of it, just add functional interface annotation. That's it. Okay, let us see these things practically. Okay, I have a class here. So this is the driver class. So when I am saying a class is a driver class, it means it has the main method. Okay, now you see I am taking an interface here. Okay. Can I call this as functional interface? No, this is not a functional interface because it has no methods, no abstract method. So to make sure that an interface is getting qualified as a functional interface, I need to place at least one abstract method. So let me place one abstract method, public abstract void m1. Okay, now I can visibly I can call this a functional interface. Okay, but the problem with this interface is this is going to remain as a functional interface as long as there is only one abstract method. Tomorrow my friend or my co-developer can come and he can say that he can add the second abstract method by the name of m2. Now can I call this as functional interface? No, this is not even a functional interface now. Okay, till yesterday it was a functional interface. Now it has become non-functional interface because one more abstract method is added. If I want to ensure that no other abstract methods are getting added, I need to annotate this as what? Functional interface. Okay, if I am annotating this interface with this annotation, then this interface will remain as the functional interface forever. What if my friend try to what if my code developer is trying to add the another method? Okay, what it says, see, the code is breaking. Invalid functional interface annotation. Annotation, I mean, A is not a functional interface. So it is throwing you, if it is reminding you, it is reminding the code developer that no other abstract methods can be added because the interface is annotated as the functional interface. So this is not possible. At any cost, you can keep only one annotation. Right? Now we have understood what is a functional interface and what does the annotation functional interface, how this annotation functional interface is defined. Okay, now we will understand the more about functional interface with respect to inheritance. Functional interface with respect to inheritance. Now you need to answer me. So this is the quiz actually. Okay, please answer me with your Java, with your core Java knowledge. Try to answer me. Okay, I have an interface here. I have interface. Let's see who is going to answer this. So there are two interfaces with me. Okay, this is the case study one. So public static, not static, I'm sorry, public abstract void m1. Okay, and this so interface name is a interface first interface name is a, second interface name is b. So two interfaces are there. Okay, I want to give a connection extension. Okay, now you tell me. So this is with respect to interfaces. Now you tell me, A is a function interface. Okay, is A is a function interface? Yes or no? If it is functional, type F5. If it not functional, type NF5. Okay, can I call A as the function interface? Okay, what is the requirement? Just go by this theory which I have just given it to you. Single abstract method. If you find only one method, then you can call it as F5. Any answers from you? Yes, A is a function interface. Good, Ratna. A is a function interface. Why A is a function interface? Because it has only one abstract method. Okay. What about B? Now you tell me B is a function interface. I'm asking you if the interface B is a function interface or non-function interface. What could be your answer? Who is that brilliant student who can answer this? What about others? Ravanjanilu has answered to F5. Question is very simple. I'm asking you if the B is the function interface or not. Ratna says not function interface. Okay, actually guys, remember this. This is the inheritance concepts. When you are using the extends keyword, okay, you are inheriting all the properties of class A. I mean, all the properties of the parent. It can be class or interface. You are what? You are inheriting all the properties and behaviors. It means, so this is also applicable. Okay, this M1 method is also applicable for, indirectly it is also applicable for interface B, because you are using extends keyword. So indirectly the interface B has access to the M1 method, which means this M1 method is already applicable for the interface B because of the extends keyword. So this is also called as what? The function interface. Are you getting this? That's not getting this inheritance concept. Are we clear? Yeah, same thing. Okay, example 2, think and say. This is just inheritance. Okay, now I am taking an interface A. Okay, think and answer. Okay, I am annotating this interface as functional function interface, right? I am taking the another interface B, interface B. So this is the case to try to answer to this. Some dot public abstract void M1 then say, I am also annotating this interface with function interface. Okay, if I ask you, so look at the annotation. I am making sure that the interface B is also functional, but I am not placing any abstract method. Okay, but still, the compiler will not throw any error. Why the compiler will not throw any error? As per the rule, A is qualified enough to be called as functional interface because of SAM. SAM is what? Single abstract method. Okay, not Samantha. Single abstract method. Okay. As per interface B extends A. B is also extending to A. Okay. So you actually don't see there is any abstract method in the interface B. But according to this extends keyword, literally this interface B has also access for this abstract method. Literally. Okay. Indirectly, okay, you don't see, but actually there is an abstract method in the interface B also because of this extends keyword. So both are quantified enough to be called as function interface and there is no violation. So this is the case 2. Are you getting this? Yes, no? This is the case 2. Right? So case 3, how does the case 3 looks like? Okay, so functional. So this is the last case that we are going to discuss. Then we will jump into the program functional interface A. Okay. Function interface B. Now let's see who is going to answer this. Public void M1 public void M2 that's A. Can I call the interface A as function interface? Okay, so just answer me this question. Okay, will I get any error if I call the interface A as functional? So interface A is functional, there will be no errors. Okay, we have only one abstract method. But when it comes to interface B, right, you might be thinking that interface B has only one abstract method. Okay, according to us, you are seeing that there is only one abstract method. The name of the method is public abstract void. Okay, I am missing the abstract keyword. Don't worry, you can keep or you can ignore. Compiler will recognize it as abstract. Either you keep, by default it is abstract only. Okay. Okay. So with respect to interface A, okay, there is no violation. It has only one abstract method. And when you look at the interface B, ideally this interface B has two abstract methods. One is which you can see, M2. One is which you don't see, M1. Because of this extends keyword, it has also access to the M1 method, or it has also access to the properties of all the interface A. So there is a violation here. So you cannot call this as what? Function interface. The code will be broken. The code is ideally going to get broken. So this is the case 3. Okay, case 1 and case 2, and you have what? You have case 3. Okay, and the case 4. Let me save this. I will send this to you in the form of email. This is the last case on top of function interface. Functional interface, and let us take that interface A. Okay, and public void public abstract void M1. Okay, let us take interface B. Okay, and I want to keep this interface B as also what? Functional interface annotation. I am taking the same method here. Okay, extends. Okay, now you tell me, can I call the interface A as functional interface? Yes, I can call this functional interface. There is no issues. According to the rule, it has only one abstract method, and and it has also got annotated with functional interface annotation. Okay. Can I call this as functional interface B? Okay, we might be thinking that this B interface B has access to the interface A's method, but there is no access because both the method names are same. So this is also the M1, this is also the M1. Overriding concept. If the method names are different, then there are two methods inside the interface B. If the method names are same, it means there is an overriding concept. So literally it has also only one method, M1 method. So this is also qualified enough to be called as what? Function interface. Only if there are different methods, then you can say that okay, the interface B has two different methods, but the methods are same. This method is overridden, this method is not visible. So only one method is also there. Only one method existed in the interface B. So that's why it is also called as what? Valid. I mean, it's valid. Right? So let us demonstrate these things in practically. So I have interface A. Okay, let me copy another function interface. This time I am taking this interface as B. Okay. So if I keep the method names different, okay, if I have method M1 here, M2 here, everything is same, method names are different, right? And if I extend this, here, now it is breaking. A is valid, it is not breaking, B is breaking. Why B is breaking? B is extended to A. In A already one abstract method is there. This abstract method is literally applicable to B also. So literally B has two B has two abstract methods. That's why this code is breaking. Right? If I remove this, okay, I have mentioned that interface can have only one abstract method. So this is going to be valid, but there is no issues with the compiler because interface B is extending A. Indirectly, this will get access to this method. You don't see something which compiler sees. So compiler is saying that this B has one abstract method by using the extends keyword. Okay, it has access to this method. That's why the code is not breaking here. Okay, the idea here is any interface at the end, the conclusion is very simple. What is a function interface? If you answer this question in the interview, that is done. You remember SAM, single abstract method, right? And any interface that has single abstract method is called as function interface. And these are the examples. And what are the uses to invoke Lambda expressions? And what is a functional interface annotation? Okay, when you want to control that interface should be the function interface forever, then you should annotate that with function interface. Okay, we have discussed some case studies about the function interface with respect to inheritance. Nothing else we done. Okay, now let us try to link the Lambda expression on the function interface now. Okay, are we ready? Yes, no? Shall we proceed to link the Lambda expression on the function interface? Okay, now focus here. Okay, this is very, very important. The question is how to invoke Lambda expressions using functional interface. Okay, let me write a small piece of code without using the Lambda expression, guys. I just want to write this small piece of code without using the Lambda expression. Without Lambda. Okay, so I'm taking an interface. Interface name of the interface is going to be A. I'm taking a functional interface. Okay, public abstract void m1. Okay, I can call this as what? Functional interface, because only one abstract method. I'm taking a class driver. Okay, and I'm taking a main method public static void main. Let me write that here. Public static void main string array args, right? And I'm using what? I need to give a connection between the class as well as the interface. Okay, you cannot actually create an object for the interface without having any connection. This interface is going to be dummy interface if you're not have any implementation classes. Okay. So I need to use what? The implements keyword. Driver is implementing. So this is the core Java concept. We have discussed these things already, implementing it. So a connection has been established between the driver class and the interface. Okay, what is the rule number 1 that we have discussed in core Java? The first rule. It is mandatory to override the abstract method. Right? Whenever a class is implementing an interface, you can implement, you are allowed to implement. At the same time, you have to follow a contract. What is that contract? Okay, you need to give the implementation, or you need to override the abstract method. That is the contract, right? So let us abide by the contract. Let us fulfill that contract, right? So after this implementation, I'm writing everything in red, so that is the requirement, that is a compulsion. Okay, so what is the contract? Override the abstract method. Give the implementation for the abstract method. Public abstract void m1, and you will give the body. In the body, you can have any kind of logic. Sum dot out dot println m1 or m1 implementation. Focus here. Focus here. So this is the core Java. This is not related to functional interface. Okay. So you have what? You are establishing a connection. Your driver class is implementing the interface. When you do this, you should also do what? You should also override the abstract method. So you have overridden the abstract method. So this is the contract between the class and interface. Okay. How I can call this abstract method? The next question. How I can call this abstract method? Okay. We need to create an object. So interface A, obj. Okay, I'm creating an object. You cannot create an object for the interface directly. So you're using what? You are using the interface name followed by new driver. The object is getting created for the driver class. Okay. The object is getting created for what? Getting created for the driver class. Right? And by using this reference variable obj.m1, you can display the output in the console. Okay, so if I want to convert this, if I want to apply this in the practical, okay, the same example I am taking. Okay, I have a functional interface and I have a driver class. Implements A. It is breaking. It is asking me to override the unimplemented methods. Okay, I have overridden it by using a shortcut. I have overridden it. Let me remove this. Okay, I need to give the implementation for this unimplemented method. Sum.out.printer m1 implementation. Okay, so I need to call the m1 method. So to call the m1 method, I am using the interface A reference obj equal to new driver, because I cannot create an object for the interface. I can create object for its implementation class, which is driver. Okay. By using this reference variable obj.m1, I can do what? I can call the method m1 method. Right? I get what? M1 implementation. So this is how you call the abstract method, or this is how you establish the connection between the driver, the class and the interface. This is the core Java concept. Okay, but I want to use Lambda expression. How can I convert this piece of code into the Lambda expression? That is the question actually. Okay. In order to convert this piece of code to the Lambda expression, okay, this is not abstract. This abstract keyword should not be there while implementation. Okay. In order to do the conversion, focus here. The same code I am taking without Lambda and now with Lambda. Your questions will be answered. With Lambda expression. Even for the Lambda expression, I need to what? I need this interface. Even for the Lambda expression, this interface is required, and I need the class. Okay. Class driver, and you have what? Public static void main method. Okay, this main method again, it is going to have the simple parameters, string array ops. Right? So without Lambda, now focus here guys, without Lambda, you need to do so many things. What are things that you have done? You need to do the implementation, and you need to override the abstract method. These two steps. Okay, these two steps you have done, but these two steps can be avoided when you use Lambda expression. When you use Lambda expression, you can avoid this. You do not want to implement driver class to interface. Directly you can do what? You can create the object reference of A obj equal to, okay, directly you can write equal to. Now here you are going to give the Lambda expression. Okay. So what was the method that you have used here? Okay. Use the same method for the Lambda expression. This access modifier is not required. This return type is not required. The method name is not required. What is the remaining thing that you have? Right, this bracket. Let me keep the bracket followed by opening closing parenthesis and followed by this line of code. System.out.println m1 implementation. Right? So I said that, okay, in the Lambda expression rules, when you have only one line of code, right, and also you need to make sure that you're using the arrow token. Very simple, guys. You are converting this method directly and you are writing the lambda expression here, right? And if you have only one piece of code, one line of code in the body of the lambda expression, these parentheses are also optional. Okay, and you can keep everything in the same line. That's it. By using the obj reference, okay, this is the obj. OBJ reference is of what type? Is of A type. What is the method that is there in the interface A? M1 method. So you call M1 method, that's it. You get the same output. See, here you need to follow this rule. You need to follow implements. Okay, this you need to establish the connection and you need to override the unimplement method. Then you can call the M1 method. But here you are calling that M1 method directly without even overriding and without even implementation. Okay, don't you think that you have reduced some lines of codes here? It's a first example. You can see so many examples. Do you understand? Thank you for rejoining. Okay, don't you think that we have reduced a huge amount of code? So let us do the same thing. Okay, so this is the with and without lambda expression. Thank you for rejoining. So let us try to run this practically. Okay, so this piece of code is without lambda expression. So when I want to use lambda expression, this implementation is not required. Okay, and you can directly convert this method. Okay, let me copy this method. Let me directly put it here. Okay, according to the lambda expression, the access modifier is not required. Isn't it? The return type is not required. The method name is not required. Right? If the body of the lambda expression has only one statement, these parentheses are also not required. Right? And to express something is a lambda expression, arrow token is required. That's it. Implementation is done. Right? And what is this reference variable type? A type. OBJ is of what type? A type. What is the method that is inside the interface here? A is an interface. What is the method that is in the interface here? M1 method. So obj.m1 directly you are calling. If you call this, what is the output in the console? Same output you will get. M1 implementation. Okay. So with lambda expression, so what you are trying to do, you are avoiding the implementation firstly, right? And you are also avoiding to override the abstract method. Look at the number of lines of code. Number of lines of code has reduced drastically. These are the lines of code. Making sense, everyone? The first example about interface. So without lambda expression and with lambda expression. If you're not understanding this logic, try to refer to my inheritance video of interface. Okay. If you understand that, you will understand this. So this is how we usually follow. When you don't know what is Java 8, so till Java 7, till 1.7, this is how you override an abstract method when you are when you are establishing a relationship or when you are trying to implement an interface by using a class. So you need to do this practice as implementation as well as overriding the abstract method. But when you convert this to Java 8, when you want to use the Java 8 language, 1.8 language or 1.8 version, I can say, okay, these things can be avoided. The piece of code can be reduced drastically. Are you getting this? We will see 3 to 4 examples in the tomorrow's class. I just want to give you the introduction. Okay, so a quick recap that I can give you now. In the interview, please always remember, when anyone is asking what is the functional interface, the answer is very simple. Just remember Sam or remember Samantha. Okay, Sam, single abstract method. That's it. If you get this keyword, answering is very easy. Any interface that has a single abstract method is called functional. Real-time examples. runnable interface as run method, only one method. Callable as call method. Comparable as compareTo method. Purpose, what is the purpose? The purpose that we have just seen, to invoke function, to invoke lambda expression. That's it. Even if you forgot this, also no issues. Remember this, to invoke lambda expression. What is the purpose of adhere function to the annotation? To ensure that the interface remains as functional forever. Okay, how to invoke lambda expression using functional interface, which you have just seen now. If you are getting these questions, answering is very easy. Lambda, don't go by the word. Don't get afraid by looking at this word lambda. Lambda is nothing. Okay, these are the so we have covered two Java 8 features. What is lambda expression? What is functional interface? Okay, please revise the topic today, then and there. Tomorrow also, every day revise this topic. If you are getting any interview questions, answering this has to be very easy. This is a nursery level things. Don't have the impression that Java 8 is difficult. Java is not at all difficult. Java 8 is very easy than Java 7. Right? Tomorrow you will revise and come. Revise everything and come. Tomorrow we will discuss 5 examples, 5 interview examples, 5 tricky examples, so that you will never forget this concept in the life. Right? Shall we wind up for the day?